The BMW car assembly plant in Regensburg, Germany, has a reputation for adopting new production methods ahead of the pack. In 2007, the world leader in precise real-time location, together with software experts IBS, were awarded a contract to provide a revolutionary new kind of industrial tool control system. Production at the Regensburg plant includes BMW 1 Series, 3 Series and Z4 sports cars. These vehicles are all produced using the same assembly line. The vehicles are assembled in the sequence in which the production planning system processes the customer orders. Therefore, a 1 Series limousine can be followed on the line by a Z4, which in turn can be followed by a 3 Series soft top. Every type and model of car is produced exactly to the customer's specification. Therefore, at any point on the assembly line where industrial tools are being used to install components, the tools must have a torque program installed, which corresponds exactly to the vehicle to be worked upon. Until the introduction of the UBiSense system, the vehicles arriving at a station on the line were identified by the worker using a barcode scanner to scan a paper label fixed to the car. Based on the vehicle identification, the IBS software would load the appropriate torque program into the tool at that station. The scanning operation wastes valuable production time. This can be as much as 6 seconds for each tool operation, as a worker is required to pick up the scanner, scan the label, and return the scanner back to its holder. There are over 140 tools in use along the 1.7 kilometers of production line, and the plant produces 1,000 vehicles per day, running multiple shifts. It is easy to imagine the significant aggregate waste of valuable production time caused by the need to scan the vehicle's identification number. The problem identified by BMW was the need to eliminate the barcode scan and remove the unproductive hours from the production process. BMW turned to help them improve efficiency and error-proof the possibility of scanning the wrong vehicle. The system uses advanced ultra-wideband radio to locate and track small tags. These tags can be attached to objects or persons and tracked to a 3D accuracy of up to 15 centimeters and 10 position updates per second. It operates like a highly accurate indoor GPS. Sensors are placed around the areas in which tracking is to take place and connected together using a standard local area network. Very short radio pulses are sent by the tags and received at the sensors, determining the direction the signal is received from, and tiny differences in signal travel time between pairs of sensors. These measurement methods result in high accuracy and high reliability within industrial environments. Even if just 2 sensors receive the signal from the tag, the position of the tag in 3D will be accurately determined. The number of tags and the number of sensors connected together may be scaled up as required to meet the specific application requirements. Special frequencies have been allocated by the regulatory authorities worldwide for ultra-wideband, ensuring that the system cannot interfere with any other wireless systems in operation at the plant. The system operates at very low power levels, less than 1,000th of the power of a mobile phone, and therefore presents no health risks. In the Regensburg plant, each vehicle on the assembly line has a attached to its bonnet at the location where the BMW emblem will finally be placed. This tag provides the unique vehicle identification, as well as enabling the precise location of the car to be calculated by the system. Each industrial tool also has a UBIC attached to it, which is programmed to identify the tool. In all Atlas Copco tools, the tag is integrated into the tool and uses the tool's power supply, resulting in automatic identification of the tool and removing the need to replace a battery. Sensors are placed along the production line at strategic locations so that they can track the movements of the cars and, in particular, the movement of the tools. When a worker brings the tool to within 40 centimeters of the car at predefined zones around the car body, where that particular tool will be used, then the system reports this proximity event to the IBS software, providing the vehicle identification and the tool identification. The software loads the correct tool program for that particular operation into the tool, and the worker receives a signal that he may begin the tightening operation. It is no longer necessary to interrupt his usual work in order to scan a label, and the efficiency of the production process is significantly improved. The most important performance indicators regarding the tool assistance system at BMW concern the reliability of operation. The proximity events must be detected to a confidence level of 99.99% in order to gain worker acceptance of the system, making the system the most reliable real-time location system in the world. Andreas Lehner, project manager at BMW in Regensburg, has stated that the introduction of the location system has resulted in the elimination of the need to scan vehicles in order to identify them, and that all the project objectives have been met, on time and within the planned budget. From the standpoint of value creation, the project has been a complete success.